And last but not least is subtracting polynomials. Remember, this is going to be super important, is that when we subtract something, we add the opposite. Keep that in mind. When we subtract a whole polynomial, we have to add the opposite of the whole polynomial. So what do I mean? Let's look at the first example. P squared minus 2p plus 5 is our first polynomial. This has 3 terms, and each one we're going to consider minus. Now this is the difference here. Pun there. The difference when we add and subtract is that now we've got subtracting a whole polynomial minus 2p squared plus p minus 4. Now let's do a quick simplify some of these things. So keep track of them. Remember, when we have minus a term, that's the same as adding the opposite. So plus negative 2p. And same thing here with that negative 4 plus negative 4. Now, but I was talking about the whole polynomial. When we subtract, we are subtracting everything in this parentheses or this polynomial. So, and I really appreciate this step in the book that you can see in example 3 here. We are going to show that the first polynomial has not changed, but the second polynomial, we can add the opposite of each term. So what does that look like? Well, add the opposite of each term. So what is the opposite of 2p squared? Well, that's negative 2p squared. What is the opposite of, this would be 1p. The opposite of 1p is negative 1p. And what is the opposite of negative 4? That is positive 4. Notice for each term, I now have this addition sign. I'm adding the opposite, but each term is now the opposite of what it was. So once I've rewritten it, I now have an adding a polynomials problem. I can find my like terms. P squared is the same as 1p squared, and there's negative 2p squared plus negative 2p squared plus negative 2p and negative 1p. We keep those negative signs with their term. And finally, plus 5 and plus, this has become positive 4. We looked for each of those. Let's do some, we can use our highlighter still for these. I found my like terms, p squared and negative 2p squared, negative 2p and negative 1p, and finally positive 5 and positive 4. We combined the like terms. And when I do that, I look at the coefficient. Positive 1 and negative 2, when I add that together, is negative 1p squared. That was our first. Then our next one, our next term is negative 2p and negative 1p. Together makes negative 3p. And finally, positive 5 plus positive 4 is simply plus 9. And before I'm done, I want to see if there's any way I could simplify this answer. Well, I've combined all my like terms, but I do see that I have negative 1p squared. I know that's the same as negative p squared. I also see plus a negative, which is the same as just subtraction. So I can rewrite it. It doesn't change my answer, it just makes it a little bit cleaner. The book also gives a great way to check these problems, and I won't require you to do this, but if you are going to check the problems, we would plug in some number. In this case, the book suggests we plug in 1. To both the original, if I plugged in 1 at the very beginning, and if I plugged in 1 at the very end, I can see if I get the same outcome by following the order of operations. This would be a great time to look through that in the book and try that. And try quick check 3. Pause the video to try that, and I'll give you your answer in a second. Alrighty, we have the set of polynomials 4y squared minus 3y plus 1 minus 6y squared minus 3y plus 3. I'm just going to show that first step where we rewrite this. I like to rewrite each of those terms that has negative. And then here's the big step. We add the opposites of each term. So the opposite of 6y squared is negative 6y squared. This would have been plus negative. So the opposite of negative 3y is positive 3y. And the opposite of 3 is negative 3. Then when we combine like terms and simplify, we actually get negative 2y squared minus 2. Notice the negative 3y and the positive 3y together makes 0, and so we don't have to include those in our answer. The practice problems are at the end of this Moodle page and on BrenWeb. I would encourage you to try those and check those before you send them in. Thanks, guys.